Good morning, I guess good afternoon, everyone. My name is Adriana Formby-Fernandez. I'm the A&E Sector User Engagement Lead out of the Industry Partnership Program, and I'm also the product coordinator for a few of the products in development. And I want to preface today by explaining that this is a preview of a Lunch and Learn series that NCEI is putting together, which the intent for is to present use cases and climate and weather variables of interest so that we can tailor presentations to kind of train the A&E sector on how to use NOAA data products and tools. If you're interested in this or throughout, please reach out to me or Russ Vos, but I will go ahead and get started. So this is what a full-length agenda would contain. For today's preview, I'm not going to be sharing too much of the tools, only 3 of them, and mostly the ones that are still in development with the industry partnership program, just as kind of a little plug and just to show you guys all the progress that has been made. But depending on the level of familiarity, this would be tailored to the group that we're presenting to. So we would start by diving into what industry engagement is, how we work with industry partners to deliver, improve, and share actionable weather and climate information. Again, this introduction could be longer or shorter, but just to put into context the relationship between the industry and NCEI. Then we would also dive into, why ASCE and NCEI work together, how dependent codes and standards are on NOAA data. We cite that, infamous report about investing $1 in resilience can lead to $13 in future damage and recovery costs, and just kind of drive home the point that we work as a partnership because of the impacts on both sides. And then for a typical crowd, we use a Mentimeter or a Menti slide to gauge the knowledge and familiarity with weather and climate data with the audience. And so this was taken from one of the lunch and learns that we've done previously with Atkins Rillis with their structures department. And we found that they were generally familiar with data, but maybe not using it too often within their day-to-day work. And this is really just for us to get a gauge of where we're at with NOAA's data being used in people's workflow. All right, so now to the fun stuff. So today I'll be walking you through 3 different products that NOAA offers for temperature, precipitation, and extreme events. The tools that are presented can again be tailored for your organization's use cases, specific variables of interest, or if there's a specific tool that you've heard about that you're interested in and you just want to see kind of a step-by-step how-to guide on how to use it, how to interact with it, then we could also provide that as well. So I will switch over slides in a second, but first I want to briefly overview what the storm events database is. So this provides information about major past events across over 55 different weather hazards. So this includes extreme storms such as tornadoes, tropical cyclones, extreme winter events, but it also includes information on things that are considered to be very rare or extreme in the sense of, like snow in Florida is captured in here. Severe drought is captured in here. Severe rainfall in San Diego is captured in here. And we've recently revitalized this tool to kind of give it a facelift. This will be fully public. It is fully publicly available right now as a beta version, but the final data set will be coming out in about less than a month. So we're very excited. So I'm going to figure out how to switch my screens and find the right one because I of course have like 100 tabs open. All right, so you should be seeing the Storm Events database screen now. So this is what the new interface looks like. If anyone's used the old one, this is a major improvement from before. And then as a quick how-to, to start a search, you'll go down to the search button. I would like to note that there is bulk data download access through here as well. So if that's something that's needed for claim validation or for putting together a report, then that's also available. But the way that this works is you can either type in a zip code, city, or address, or we have this fun little pen tool where you can draw on the map and it grabs all of the counties that you've drawn on. So let me zoom in here. So you can see it's grabbed all of these different counties let's say that I don't want this one, don't want this one. I can just keep clicking until I get down to whichever counties I want access to. And then I can also go over here to this list and pick which ones I want. As I mentioned, there are 55 different event types that you can pick from. Um, they, again, range from hurricane to wind to hail, lightning, tsunami, sneaker waves, wildfire, volcanic ash, all sorts of fun things. So we'll go ahead and just do the strong wind. And then you can filter these, sorry, you can filter these even further if you want to get specific winds at a certain knots or stronger. For flood, you can determine it by the cause, hail, it filters, and tornado, it filters as well. So I'm going to leave it with all the wind filters, and then we'll just go ahead and grab all of 2025 just to make it easier to find an event. And this record does go through all the way. Maybe I'll just do it to today. It is kind of cut off on my screen. Okay. Um, this does go back all the way to 1950. So there are probably millions and millions of records on here. So once you perform a search, you'll get a nice little results summary table right up here. And that's just to make it a little easier to determine what events you're looking for. And so we've heard that this can be used in the insurance sector for claim validation, but for some engineering use cases, we've heard that this could be helpful for post-event analysis or post-event repair. So you can verify the conditions and the impact of whatever event it was. So if you're doing like structural forensics or that type of work, then you can use this to get a PDF report that then could be certified. So this is a list of all the results, all the different reports that have come in. So I'll just click this first one and then share this tab. And so this is what we call an event page. So this has all the details about this specific event that happened in Bradley, Tennessee in February of 2025. And so you can see from the event narrative that there was a large tree that was blown down onto a house. Oh, so I picked a good one for engineering applications. So if you're trying to, ensure that you're working with the insurance correctly because of the roof damages that occurred, here's a good example. And then this could also be linked into an episode. And what an episode is all of the events that have occurred within one kind of broad event. So I'll share this tab instead. And then here we see that it looks like it was a strong synoptic system with heavy rainfall, and that led to the heavy winds, the tree landing on somebody's house, and you can see all of the places where there were related events that occurred. So here we have some flash flooding, it looks like some severe winds. And so all of this information can get put together, like I said, into a PDF that they can be certified. So then for kind of that legality, making sure that everything is up to spec across the insurance sector, across the legal sector, and across A&E, then you can all have the same information going forward. So that's a little bit about SED. I'm going to switch screens again. The next tool that I'm going to share is the typical meteorological year. And so I know this has been a big one coming out of the industry proving grounds or the industry partnership, mainly because it contains future projections, which is very exciting, and also because this was a big push from the architecture community and for mechanical engineers for HVAC, heating and cooling, and building envelope design. This is a point-and-click interface and data set with 1 year's worth of climatological data that's considered typical from a record of many years. And it spans from 1998 to 2022 for the historical component, and then 2025 to 2100 for the future projections component. This is station-based, and it spreads across CONUS, Alaska, Hawaii, Puerto Rico, and the US Virgin Islands. And I think I'm freezing, so I'm going to turn my video off.
I haven't noticed a problem, so.
Okay, it was happening on my end. I'll leave it up then, just in case. Okay, and then switch screens again, bear with me. All right, so you should be seeing the typical meteorological year interface. What we have up here first is a what we call a splash screen, just to kind of give some introductory information, a contact point, kind of explain where the data is coming from, and then it launches right into what we call our quick start guide, which is a how-to for the application itself. I'm going to give that, so I'm going to exit out of this for now, but just know that that is there. So in case you are confused on something later on, you can reference that again. And then I'm also going to close this banner just so we see more of the screen. And so you can see all of these like bluish purple dots are all of the stations that we have. The TMY calculation is very specific, and so we had to look for stations that contained 30 years of data that were consecutive, didn't have large data gaps. There's a bunch of also of other qualifiers. Um, and so future enhancements to this would include adding more stations. And these yellow, it's a it's a yellow diamond with a blue outline, which is why it changes color when we zoom in. But one of the things you can do with this is click on any spot on the map. So let's say you're, I don't know, building a a plant that is going to be in this rural area here. You can type in the address, you can place your pin, and then it'll select for you the closest station. And then it'll also provide instructions on the distance to that station from the point that you've selected, the station ID so you can cross-reference that with other data sources, and then the direction of the station versus the point you've picked. Um, and then in the output file, we also give the elevation of the station so that you can use that to determine if this was a good station for this analysis, or if you need to pick a different one. So let's say I actually needed this point over here because that's going to be a better representation. I can just move my pin a little bit closer. You can also search by address or coordinates, and so that would be right up here on the nav bar. For the time period, you can pick, as I mentioned before, the historical component, which is 1998 to 2022. And then the future components start with 2011 to 2035. Um, Robin, I see your comment. I'm going to answer those at the end, so I don't have to switch too many times. But the future components do start in 2011, mainly because we were trying to give kind of a near-term future projection. But again, we have to follow this 25 to 30 year projection scheme for or projection range for the TMY calculation. And so we have 2011 to 2035, 2026 to 2050, 2051 to 2075, and then 2076 to 2100. So I'm going to leave it with the historical for now. The next thing that users can pick is the weighting scheme that is used, which is applied to the core variables within the TMY calculation. And this is extremely important for determining which climate variable is most impactful for your analysis. So standard has all the variables at equal weights. Sandia, Garlic-Ice, and SRDB are all of the ones from the literature that we found. But then one of the things that is kind of a big ticket item with our product is this custom weighting feature. And so when discussing this with engineers who live in like cold regions such as Alaska and Wyoming, we found that for them sometimes wind speed is way more important than solar radiation. Sometimes solar radiation is really important, and so they want to boost that percentage up. Air temperature might be something that's weighed more heavily in some places than others. And so this gives the users the flexibility to be able to alter the calculation, to alter the output so that you can better perform this building energy analysis. So I'm going to leave this as standard for now. And then these are all the additional variables that are presented as outputs along with the data from the calculation. We also allow users to change the units just in case you're working with someone in, I don't know, the scientific realm and they want to use SI, or if you have to use it in US customary, we want to give users that option. And then this check mark down here just says, I understand this is experimental. I agree to download, and then you can download a zip file. I'm going to switch back over to my PowerPoint. This is an example of what the CSV output looks like. So when you download your zip file, you'll receive a CSV file that looks like this. You'll receive an energy plus weather, an EPW file, which is one of the software systems that does building energy analysis that our users who had helped us with development had expressed would be most helpful. They have very specific requirements on how everything is built, and so we wanted to make it easier to just kind of put in all of your query information and then plug it into your system. And then there is also a metadata file which contains information on when the data was accessed. So if needed, you could go back and have a record of how all these calculations were made. But you can see it's every hour for a whole year. Uh, the data comes from, like, the year that is listed here is where the data from that month is coming from. So for January, you might have 2009, but for February, it might be 2016, and that just represents when the most typical month occurred. And this is in line with the methodologies for other TMY tab calculations. And then this is an example of what these daily means look like. So just as a view of what this data actually is, these outputs can be used to determine typical conditions over the span of a year for right sizing. And then, as I mentioned, they can be used in Energy Plus software. So this is just kind of nice to look at. Top one is temperature. Look at that, it gets hotter in the summer. No surprise there. Solar radiation has these spikes and falls from day and night. And then the wind speed actually gets lower in the summer in Asheville, which is surprising. But again, this is a tool that can be used for heating and cooling systems, building energy analysis, a lot of HVAC, building envelope, that kind of stuff. All right, and then the last tool that I'm going to show today, this tool is not yet out. We are super, super close. We're hoping to have this out to the public in September. So we've done our final testing, we're doing our QA and QC checks right now, and then we have to go through a review process with NCEI, but we are super, super close. So this is the US Precipitation Time Series Explorer, or PTE for short. This is a point-and-click map interface that provides a localized time series of precipitation estimates that is transformed from gridded precipitation data. And so this is the pancakes to churros method that some of you may have heard before, where we take a stack of pancakes or gridded maps, and then we extrude out a churro or a time series record from that stack of maps. This data is available for CONUS, Alaska, Hawaii, Guam, and the Caribbean, including Puerto Rico and the US Virgin Islands. So we tried to get as big of a spread as we could. And it's hourly data from 2020 to current that is updated at near real time. And so this is especially useful to analyze risk of near future rainfall events because you can get essentially live precipitation data from events that may be happening within the last 24 hours. So for example, if a location received 15 inches of rain over the last 3 days, then you could use this to determine if there would be any impacts with soil or watershed information to determine if there's possible flood risks in the near future. So I'm going to give a quick demonstration of this tool. There we go. And so this operates very similarly to TMY, where you can click on the map or you can type in an address or coordinates. So I'm going to go ahead and maybe we'll try Arizona so that the system doesn't crash by pulling a state that has too much rain or that doesn't take too long. And then I'll go ahead and search for rain from the start of 2025 all the way to the end of 2025. And all of this data is given in UTC. And so that's something that we've heard from users could be helpful, could also be helpful to just have it in your local time zone. And so we do also give the time zone conversions at the bottom. For right now, we're offering hourly precipitation estimates and then the percent of the estimated flash flooding threshold, or the technical name for this is the quantitative precipitation estimate over flash flood guidance. This is essentially just tells you how likely it is that the flash flooding threshold has been broken. And so we'll generate this time series. It might just take a minute or two. We have also been told from other engineering, transportation companies and users that we've talked to that this could also be used to determine the amount of rain that caused a failure of certain systems. So HNTB gave us a great use case where they were using this data and similar data to determine when a rail track had flooded over and something had failed within the bridge for the railroad to determine how much rain had fallen. And there we go. So this is the QPE, or the hourly precipitation estimate, for a year in Arizona. Not surprising, not a lot of spikes, not a lot of data. But we do offer this data as a chart, as seen here, and then also as a table to make it a little easier to see. So it's essentially like a CSV file, but you can see it on your phone. And all of this, or sorry, this entire application is available on mobile. And so we've made special designs so that you'd be able to pull it up on your phone if you're out in the field and you need to just do something really quick. And then this is the QPE over FFG, again, seen as a chart, and then also viewed as a table. And this is available for download as a CSV and also a PNG. All right, let me flip back one last time. So these are all of the tools that IPG has developed in conjunction with ASCE and with the ASC NOAA Task Force and our A&E working group. So these are the ones that I wanted to highlight today, just as, again, that little plug. But as I mentioned before, this Lunch and Learn series can really be adapted to whatever tools your organization is interested in. And so for other organizations, we've done specialized presentations that included Climate at a Glance, Climate Atlas, the Sea Level Rise Calculator, the Sea Level Rise Viewer, Storm Events Database, and others. And so it's really just up to whatever would be most beneficial for your group or your organization. And then we would lead into a Q&A discussion when we do this lunch and learn so that everyone can have a chance to really like dive down deep and ask the questions on how do we use this in practice, or what does this even mean, or how do we use this tool. And then we also have just a few questions on how to gauge for what tool was most exciting, if they feel like they've been able to understand this product and be able to integrate it into their work, and then how comfortable they are accessing the data and integrating it. And again, this is just for us to get a better read on how to make our tools better as well. And that is it for today. As I mentioned, if you're interested in having one of these for your organization, please let us know. You can direct questions either to myself or to Russ or anyone else at the Industry Partnership Program, Allison Crimmins, and then she can direct it back to us. And I will take any questions. And I'll start with Robin's. Let me stop sharing this and then look at this question. Any chance of being able to use geocodes instead of an address? I do not actually know what a geocode is. So I'm gonna say no for now,
It's
but I can look
latitude
into
and longitude.
Oh, yes. Yes, yes, yes. Yeah,
Because
you can use coordinates.
you kept saying address or use the map, and a lot of things in rural areas you don't have that. You don't have an address. Okay, so you
Cool.
can.
Or Adriana, if you use what's called the NICE code, that's the insurance code that typically also has the lat longitude or slash geocode in it. So
Okay. Learn something new every day.
All right.
Yeah, Dennis.
Yeah. I think why don't we, instead of putting your questions in the chat, just go ahead and raise your hand. I think it'll be a little bit more interactive that way. But go ahead, Dennis.
Okay. I had attended one of your sessions outside of this group, and I mapped the MRMS data that you provided. I put it was it was in a, I'm going to just admit, I used Claude Code to extract the data out of the site you provided, that AWS. I put it in the chat.
Mhm.
And it was interesting because it was the precipitation data for a city near Baton Rouge that I was evaluating. And that basically is what the precipitation tool is going to do, correct? Is that data that's in that site just there? It's like the raw data that
Mhm.
is not up on, okay. I
Yeah.
just wanted to make sure. And the purpose of that data is to provide a bridge between Atlas 14 and Atlas 15. Is that correct? I just want to
Um,
understand that.
yeah, so a couple things before I answer the last question. Um, the data that's in that bucket is our raw input sources, and it actually comes from the MRMS product viewer, which is that like gridded map product. And then so CISS, which is the Cooperative Institute of something science, one of those acronyms, that's based out of NC. It's based with the NCICS, the NC cooperation with NOAA. Um, I
Okay.
need to learn all of these acronyms. Anyways, they've put all of that data, they've reprocessed it from the gridded maps into a Parquet format, which is why it looks a little
Okay.
like weird in the bucket. It's not a
Yes.
like a CSV or anything. And so that data is in
Yes.
there to be used for whatever other purposes. And then our interface, it just makes it a little bit easier to grab that data. And then once we launch our interface, we're also launching a Python
Okay.
notebook that allows you to do multiple location queries at the same time. So right now the interface only allows you to
Okay.
do one location at a time, but it would kind of walk you through how to use that process. And so yeah, it's kind of a bridge between the raw data and then our interface, kind of showing all the breadcrumbs of how we get from RMRS to our product. To point to the Atlas 14-15 question, there is not a direct link between our product and Atlas 14 and 15, um, but I think we do have similar data. Excuse me. And I can't speak too much about Atlas 14 because I'm not involved in that product too much. But
Okay. I just wanted to make sure I may have misunderstood when you presented it the first time I saw this, but I did because that bucket is unusual. If anybody wants to go into that link, they can look. I had to send, I guess I'm not an expert at Claude, but it sends the agent in there and it uses Python and all that. It extracts what you want and then it'll put it in a spreadsheet. And it also can create, like a surface and you could put it in a GIS map as well, which is what I did. And I was ground truthing some modeling runs that were done for this particular municipality. So I appreciate that. Thank you.
yeah.
Other questions for Adriana? We've got plenty of time. Okay, well then I've got one, Adriana. Would you mind going back to your discussion of the TMY, the
Yeah.
typical meteorological year, and talk a little bit more about the future conditions piece of it? Obviously, for engineering design, we're very interested in future conditions, and so that to me was the part of the TMY process that kind of evolved from when it was first presented to me, I don't know, 2 years ago. So can you just talk a little bit about that, how those numbers come to be, what they represent, to whatever you're comfortable with?
Yeah. Let me pull up my slides again, kind of to just guide this a little bit. Ooh, there it is. Okay. So I'm going to start by saying that the calculation behind TMY is extremely nuanced. It's very complex. And so if I make a mess of this, I will point everyone to our technical user guide for more information. But essentially what the the TMY calculation does is it takes the record of 25 years, it creates a cumulative distribution function, and it finds the most typical month and year from all of the 25 years of data. And so this is where you get for January, the data comes from 2009, but for February it could be 2016, and then March could come from 2015. And so it applies the weighting scheme, it does this analysis to find the most typical month, sorry, the most typical year for every month for the entire record. So that's just kind of like base, that's the historical component. And then in the future component, we add on to that. And so we essentially run a historical analysis. And then we take the climate projections from the SPHERE model, the GFDL SPHERE model, and we look at the difference between the projected value and the value that came out of the TMY output. And so for temperature, for example, it might be like a, I don't know, like a +2 applied to the month of January, and then a +3 applied to the month of February, and so on and so forth. And then percent differences for relative humidity and stuff like that. And so we apply the changes using a strategy called morphing. And I may be oversimplifying this, but it is essentially a morphing technique. And so we look at what the expected TMY outcome is, or sorry, what the actual TMY output was for the historical, looked at the future projections and say, okay, how do we get from here to there, essentially? Apply those changes, and then that becomes the projection output. Um, does that help?
Yeah, and then can you go back to your interface? I just wanted to look at the periods that you can pull. So
Yeah.
it's like basically every 25 years. Is that how?
Yes. Yeah. So the TMY calculation from the ISO standard uses 25 years as a kind of baseline amount of time to pull.
Hmm.
And so we essentially backtracked from the SPEAR model. We were able to get all the way out to 2100. And so we backtracked 25 years from each one, which is how we kind of got to this 2011 to 2035, which isn't really in the future for the most part, but
Right. And then if you pick a feature, let's just say 2076 to 2100, can you do all the same customization, or does that kind of collapse down into something more? Um, I'm trying to understand um, from a user perspective how complex this gets, right?
Mhm. Yeah.
So does everything work the same way? You're just out into a future projected value, I guess?
For the most part, yeah. There are a couple variables that we don't have data for. So like snow depth and sky cover, we don't have the projection data for that. And then some of the other variables, I think the wind variable in particular, and then station level pressure, those don't change, or the amount of change is not significant enough. And we go into detail with what gets changed and what doesn't get changed in the user guide. But yeah, for the most part, everything stays the same. If you apply a weighting scheme, it'll it'll act the same as you do for the historical. It'll apply those weighting schemes, make those changes. It's just the matter of the things that are hard to predict or hard to project out are we have a little caveat embedded with those. So
Okay, no, that sounds good. And then the user guide, is there an obvious link? I mean, obviously we record these and we share them with different members of the community. So if there's a link, that would be handy for us to capture here.
yeah,
Where's the
let me
user guide? Is that what you're showing me?
yeah, so this is the product page. And so if you type in typical meteorological year NOAA, it should take you to this page. Should be one of the first Google searches. And then if you go down to technical user guide, then it pops up as a PDF. And we are in the process of writing a paper. It's writing a paper takes some time, and we wanted to make sure we had all the information out for people. And so this is a very thorough. Let me share this really quick. We've listed out every single step, and we make it so that we've tried to write it so that anybody could do the calculation on their own if they wanted to. So we include details on everything. It is extremely thorough. But yeah, it's all located. All of the supplemental information is on the landing page, which I've just shared. And then the link to the interface is also on that page.
All right,
So
excellent. Thank you.
yeah.
And then I got a quick question for Megan. Megan, did we announce the availability of the TMY through the news blast last month?
We did through a prior newsletter. Yes, we have.
Okay. We just need to I think we need to just keep advertising that.
Okay.
Joe.
I I wanted to go back to Dennis's question about the rainfall data. Just to inform you, the MRMS is a radar informed product. And so the main use for that is because you get a spatial distribution at a very fine scale. So, for example, someone wanted to do a small watershed modeling of an extreme event. They would have sort of a time series, and they would have spatial extent at a very small scale, as opposed to something like Atlas 14, which has a long record and they can do exceedance probabilities. So that's sort of the two ways of looking at extremes, a single event or a probabilistic distribution. And those are sort of different approaches. Is that right? The better way to say it, Adriana, does that characterize what that Precip the Precip Explorer is intended to do?
Yes. Yeah. Thank you for
Yeah.
summarizing that. Yeah.
Yeah. So it's very different applications, but both related to extremes. So there you have it. I hope that helps you sort of contextualize those a bit.
No, that's helpful. Thank you, Joe.
Yeah.
Any other questions for Adriana? All right. Well, then, we're
Dan, are we
go
are
ahead.
we tight on time? Do we
No,
have something
not at
I can
all.
show? Okay. Can you give me the ability to share what I
I
did
believe
so I could
everybody
show?
should have.
Okay. Let's
Yes, they
see.
should. They should. So Dennis, if you are having issues, we can work offline or not offline. We can work
Let me
through
let me
direct
let me
message.
let me try to
You
do
see the
this.
share? Yeah, there you
See,
go.
you tell
There we go.
tell me if you can see this.
It's coming. It's just taking a
Okay.
minute.
I turn the aerial off. Maybe that'll help.
There we go. We see it.
There we go.
Okay. So basically, this is a new municipality south of Baton Rouge, and these are creeks that flow into this river here. And the state had a big I would say maybe $130 million HEC-RAS program called Louisiana Watershed Initiative. It was funded by HUD. Anyway, all I did was take the raster files. I use Claude Code to do this and plot these different damage calculations because I was going to run a BCA on putting some flood control in here. And there were three watersheds in here. And so after I got all the damages and I put it in spreadsheets and created these map viewers, I did, I'm going to show you what I did with the other data. Give me a second. I too can make a mess of things with all this sharing business, but let's see. I mean, I just applaud uh, what NOAA's doing because what I can do now is again, those are the structures. This is the MRMS data that's plotted, and I could zoom in to any particular area and then look at. Let me see where I have. I'm not seeing. I had one example. Maybe it's up here. Oh yeah, here it is right here. So like this little subdivision floods and it tells you where it is. It's in Bayou Manchac watershed. And then I can look at the 2025, 3.10 inches is from the MRMS data in that particular case. Anyway, it was very helpful to me, and I just wanted to share, I'm going to turn these off, in real time how I was able to use it.
No, that's amazing. Thank you for sharing.
Yeah. So I look forward to the actual viewer because I used, the Claude Code platform to extract that data, and I would feel more confident about myself going through another processing of that raw data is basically what I was getting at. And I did look up, Joe, what the multi-radar, multi-sensor data how it was calculated, and I did some research on that as
Oh
well.
yeah.
But
Yeah, I
thank
just
y'all for.
I, that was really interesting when you put the 168 year, whatever you put the frequency analysis, is that was just taking those values and then using Atlas 14 to back out what the return period was on those.
Yeah,
Um,
I will show you it. I created the spreadsheet based on the different. Uh, so this shows just the years in which that data was collected, and then it does an Atlas 14 comparison in this spreadsheet.
okay.
What I'm trying to do, okay, I'm not trying to be the meteorologist, okay, or
Mhm.
climate scientist. I just want to run a benefit cost analysis. And I want to make sure that the water levels that I see from the output of a HEC-RAS model are believable. And that's how I ground truth it. And so I just look at a lot of different data sets to make sure that the modeler is not, causing some odd outcome. And then that makes my BCA, more, uh, I guess, stronger to review, a stronger BCA for review is what I'm getting at. So I'll provide different ground truth checks in a submittal, and that's
Well,
that's how I use it.
yeah, that's very interesting.
But any,
Tying those two together really is works really well, I think. Yeah.
Well, I mean, if anybody, I could talk a lot about Claude Code. I don't know a lot about it. It seems like it was designed by people that know how to like hack systems. I mean, they're very smart. These agents, you send them out, they'll collect data from every public domain source. What's great about it is that you can do that. It's like it knows how to read the code behind the website. So it'll collect all the raw data, and then you can overlay it into a map viewer to ground truth the work that you're doing. Some of it might be generated in a closed environment, not out in the open source. And it's a good way to ground truth your work. And that's what I use that platform for. I don't really understand how smart it is, but I could tell you it's very smart. Uh, it, I've done all kinds of different BCAs, including where I've pulled vessel movements from the core. They have a spreadsheet that's 550,000 rows, long, and it'll pull data on vessel movements anywhere in the country that you can use in a DOT business cost, a benefit cost analysis. Anyway, it's I think you could have a session on Claude Code and how it helps you process data. I think that is something that we could maybe look at talking about in the future. But I use it and I don't really totally understand
Yeah.
how it works because I just use it as a tool. It's like I'm not a programmer, but it's been
Yeah.
very helpful to my work. Yeah.
That's
Great.
good. I got a quick question for you, Dennis. I know we're going to be talking. ASCE is very interested in AI and its use in engineering practice, so I think there's going to be a lot of content there generated, especially going into ASCE 2027. But my question is, with these BCAs, I assume that these BCAs are based on current conditions as opposed to future conditions, and that's just the way that they're
Well,
expected to be performed.
no, the norm. So there's, a regular conventional benefit cost FEMA's toolkit, which is just a spreadsheet, and you basically input all the work is really before you enter it into their toolkit. But what you'll do is you'll get a model that'll run, a 10, 25, 50, 100-year event for existing conditions. Then they'll place the project in the model and they'll run 10, 25, 50, 100-year events. And those water surface elevations that get lowered are then I use to build a loss avoidance spreadsheet, which is based on depth damage functions, which are empirically based, basically saying like, if you have a foot of water, you have 35% damage. If you have 2 feet of water, you have 65, whatever it is. It's a graduated scale. It's not linear. And you also pull what we call building replacement values, which you can either get through RS means, or there are a lot of different services that provide that. And it's like a multiplication table, and you just multiply, the water surface elevations, which then gives you the percentage of the structure that's damaged, and then the value of the structure, and then you can calculate the damages. And you do that before and after the project, and that's what you input into the BCA. It's tedious, but it's really not complicated because all you're doing is you're looking at the cost of the project, included in the maintenance of the project over the design life of the project. And then you're looking at the benefits, and the benefits are when you take damages and you basically move them to the other side of the ledger and they become a benefit because you're removing the damage. So if you have like 10 million in damages, hypothetical, and you bring it down to 1 million in damages, you always have residual damages. And say you have a $3 million project, you're going to be cost effective. You could just do that in your head. $3 million cost. You have so
Right.
much per
Right.
year
But
of
the
maintenance,
premise
and
is
then
that you're using current conditions. You're not talking about more
yeah.
intense rainfall in 75 years that would reduce the benefit. Is that correct?
Well, you have the ability, and FEMA was going this way during Biden's administration, where you can have climate projection in there, but you do already have that. You have sea level rise projections if you're in a coastal setting in your model. It's built into your models. So just what you're putting into the actual BCA itself, which is a very simple little toolkit that helps you calculate the benefit cost
Mhm.
ratio. FEMA was trying to put climate prediction into the BCA toolkit. And they pulled that back, of course. And honestly, that really does belong with the modeler, right? Don't you think? If you're looking
Well,
at
you're
a,
pulling rainfall data, so that to me, I mean, like if you're pulling rainfall data that is current versus rainfall data
right,
in the future, we expect rainfall patterns to change. And really, where I'm going with this is Atlas 15, Volume 1 and Volume 2. And I think in future calls, we're going to be wanting to have more of an exploration of what is the significance of Atlas 15, Volume 2 and how do users, we need to start people thinking about how they're going to use that. So that's really where I'm going. I just used you because you were already kind of partway
yeah.
down the pipe.
But I'll just tell you, these modelers, they'll use Atlas 14 right now, right? And they'll pull the 10. The typical is a 10, 25, 50, 100 year run. And they'll look at those levels. And if they're in an area where they have compound flooding, they'll then have a coastal influence and they'll add sea level rise to
Right,
it.
right. That would make sense.